Now, a couple of things, but at least do the next two of them. Because the next two numbers are kind of important. Now, first of all, when we first started lecturing on 1.1, we pointed out what kind of an equation this was. If you have an x to the first and a y to the first, it's a linear equation. Okay? That was from the very first thing that we did. Algebraic function. F of x equals x to the first. If it's an x to the first, and basically this is a y on the other side, y equals something times x, then the first degree is linear. X is 0. So 3 times 0 minus 2y equals 2. 3 times 0 is 0. So all we have left is negative 2y equals positive 2. So y both sides by negative 2y. So the y value is negative 1. So x is 0, y is negative 1. And the reason why I want to keep going with one more is because people panic when they see a fraction. Fraction panic. So now we're putting 2/3 in. So 3 times, plug in 2/3, minus 2y equals 2. Look how nice this is. 3 times 2/3. 3 over 1 times 2 over 6. The 3 is reduced, so it's just 2. Minus 2y equals 2. Subtract 2. Negative 2y equals 0. By negative 2. All right. $1 million question. 0 divided by negative 2 is 0. Do not forget, 0 divided by any number except 0, 0. Any number except 0 divided by 0. Undefined. Yes, divided by 0. No, that's going to be part of it. So 2/3 goes in, 0 comes out. 2/3 for x and 0 for y. So if you go to graph this, at negative 2, y is negative 4. At negative 2, we go down 4, so right here. Now, here's what I want when you graph it. If you graph a point that's in the quadrants, then I expect that you label it with its ordered pair. Don't expect that I'm going to count it. Label it with its ordered pair. That would just be negative 2, negative 4. 0, negative 1. At x equals 0, y is negative 1. Right there. Now here's the good news. If it's on the y-axis or the x-axis, you don't have to show an ordered pair. You can just label it like a number line, that's negative 1. But kind of lets you off the hook when you're labeling a point on an axis, because I don't like having it, if I do it, but I don't like having to take a point away when people get confused, students get confused, they go like this, -1, 0. The ordered pair is x then y. This is not -1, 0. -1, 0 is over here. If you label it with an ordered pair, it's 0 for x, -1 for y. So you've got to be really careful if you're on an axis, people get confused. So that's why, if you're on an axis, you can just use a number line, that's -1. And then x is 2/3, y is 0. X is 2/3. So here's 1. 2/3 is a little bit less than 1. So right there, it's on the x-axis. If you go 2/3 to the right and 0 on the left. So you just label it out as a 2/3. And if you kept plugging in the rest of the points, they would all fall in that line. When you graph your line, take the straight edge. Take an ID card, driver's license, credit card, whatever it is, draw something nice and straight. And when you graph lines, make sure you put arrows on because you want forever. So when you graph height for a line, the minimum number of points you need to make a line, to establish a line, is, I don't care which two. That's just practice because they're picking it up from where it's not at the top, slowly and gradually. When we get to the next section, we don't want to plug in points. We don't want to plug in numbers. We want to look at the equation and just know how to graph a line. All right. Any other questions from the homework? I know we got off. Go ahead. 35. Use the graph utility. So graph calculator. Yeah. Graph utility is graph calculator. No. Use graph utility, graph equation. Use a standard viewing window, approximate any x and y intersection graph. Y equals 2x over x minus 1. My equation has been 2x. I'm going to divide by in the denominator in order to make sure. Now, the calculators most of you are checking out of the library, the graphing calculator in the library, TA or when you hit divide by, it usually because the screen will pop up and like just like you, it shows right here. And it's going to type in under the denominator. Mine's old school, it doesn't do that. I have to divide by, and I want to divide by the entire denominator. If I do this, if I do the x minus 1, it's not going to work. What is it, guys? That would be air. It would just be ugly. So that, that would be horizontal line 1. Right? Because what it just typed in is this. Y equals 2x over x then minus 1. That's what the calculator is thinking I just typed in. It's not putting x minus 1 as a full thing under the denominator. it's doing 2x and then over an x and then minus a 1 after. If I wanted to divide by all of x minus 1, then when I type it in, I have to put 2x divided by double parentheses x minus 1. That way it stays as an entire grouping of numbers. Back and insert. And then it's a standard, and window, a standard window. So there's your zoom. Number 6 is Z standard. Okay, Z standard. It said approximate in x or y intercepts for the graph. So if I look at my graph in this window, it looks like the x-intercept where it crosses the x-axis, it crosses right here at 0. And it looks like the y-intercept where it's crossing the y-axis, it's also crossing the y-axis here at 0. So it looks like the x-intercept is 0 and the y-intercept is 0. That's what it looks approximately. Now, I can actually calculate. If you go to trace, and right here above trace, it says calc in the blue. So I hit second. Calc, and you have all these options. But what I want is, I want to find the 0. I want to find the x-intercept. That's what a 0 is. Where does it cross the x-axis? When does y equal 0? So option 2. Well, and I want to calculate. Now here it's asking me a couple of questions. Problem. Left bound, right bound. I need to tell it where I want it to look. I need to tell it, I want you to try to find, because it looks like it's at 0. So I need to move the tracer, that cursor a little bit to the left, and I want the calculator to look between this x coordinate, if I hit enter, and then right back. I want them to be that left. Now I'm going to get on the right-hand side of where I think it might be. So now that's positive. So between that negative and that positive, I want to find the 0. So I hit enter. Now this next piece, I don't know, I've never figured out why they do this. Well, I want to take a guess. I don't know. I don't know if they're asking me if they want me to guess it, or do I want the calculator? I have no idea. Just hit enter. One more time. And it's at 0, 0. So where does it cross the x-axis? At 0. Where does it cross the y-axis? At 0. The x-intercept is 0, the y-intercept. This looks like exactly, because it doesn't cross it. If I plug in 0.1, this does not equal 0. Okay. If I let y equal 0.1, I will get x equal 0. If I let x equal 0, 2 times 0 is 0. X minus 0 minus 1 is negative 1. 0 divided by negative 1. Y equals 0. If I let this equal 0, well, the only way we could get 0 for y is if up here 2 times x equals 0. Yeah, well, that's how you do it algebraically. What did I call this phenomenon right here? Because you see how you get close right here, it's positive 1. And as we get close to positive 1, this graph goes down. But on this side, it's coming from up here and it's going this way. What did I call that phenomenon? That name. Vertical sum. That's a function. Vertical. Well, no, there is a vertical shift, but that dotted line right there, described it like a wall that the graph gets infinitely close to but can't touch. A vertical asymptote. This right here, at x equals 1 is the vertical asymptote. That's the vertical asymptote. That's what the graph gets infinitely close to but can't touch, because if I do that, I try to plug in 1. I get y equals 2 times 1 over 1 minus 1. So I get y equals 2 over 0. You can't divide by 0. This function is undefined if I try to plug in 1. It's not defined for 1. The domain is all real numbers except the number 1. You plug in any 1 except you can't plug in 1. If you plug in 1, you get undefined. That's why there's a wall there. And all you can do is get infinitely close. I can plug in, 0.9, 0.99, 0.999, 0.999, 0.999, and I will get numbers that go way down here. If I plug in 1.000000001, I'm way up there. I plug in 1.001, I'm going to move down. 1.001, further down. I plug in 2, I'm right here. Right? That's what we did. What we did last week was we looked at f of x. The parent function was 1 over x. That's the one that we looked at, this guy right here. And this one has its asymptote, 1 over 0. You can't plug 0. And the graph looks like this on this side, and over here it looks like that. You can't plug 0. One over x versus 2x over x minus 1. This one. This one. Vertical. Asymptote. So this is that x equals 0. You can't plug in 0. Now this guy over here. Asymptote. Okay. You can't plug in 1 if that x equals 1. Why the change? This is not part of 1.1, it's not part of 1.2, it's alluding to foreshadowing. So I'll give you What is the difference between those two functions or those two equations that might lead to the difference in the aspect? They both have aspects. Right? Right, so 0 is fine, but what's not on here? 0, 0 minus 1, 0 over negative 1, that's fine. But I can't plug in what? 1. That's why they asked for it. So what happens if this asymptote is shifted horizontally? How many? To the, but what do you see? You see minus 1, don't you? You see minus 1, but it went in the positive direction. Okay, perfect. This is the parent function. That means graphs that have a a rational function with x in the denominator tend to look like this. And tend to look like this. So if we expand on this, f of x equals a over x minus h and then plus k. Again, foreshadowing that part today. X minus h, when you mess with x, horizontal shift. The negative in this formula is built in, it is in there. And it's always true about the horizontal shift. If it's not, the horizontal shift is not this x. And it's always going to be minus that h. The horizontal shift of the x is going to be minus an h. For parabolas, f of x equals ax minus h squared and then plus k. For square roots, f of x equals a square root x minus h and then plus k. For logarithms, f of x equals a e to the x minus 2 exponential e to the x minus h plus k. Logarithm f of x equals a natural log parentheses x minus h plus k. Trig f of x is equal to a cosecant parentheses of b x minus h and then plus k. Because it's in there with x, it would have to be in parentheses to mess with x, because that's part of the function. It's always a built-in negative. So when you extract the horizontal shift, when you take it out of the equation, the negative is already there. So when you take out the h, it's opposite sign. It would be opposite sign. So I tell my students in algebra 2, they're not going to agree. It's not opposite for each. It's opposite sign. So if this was x plus 1, then it would have been shifted 1 to the left. Because this would have been x minus in negative 1. That's how you do a plus 1, each is a negative 1, or as much as this. And when you think about it, what would make 0 negative? Negative 1. X does not equal negative 1. That's the horizontal, or sorry, vertical aspect. Take out the opposite sign. All the k's have got pluses in front of them. So for the k, keep the sign. K for keep. Whatever it takes to know which one is which, you got to do. I don't like memorizing. I don't like memorizing. I would rather know or have some kind of process of being able to figure it out. Because my brain, my memory is like, it's practical. It really is. I still can't figure that move with Bob Keller and James Jameson. That was 35. Any others? I know we did 55 as an actual question for the notes. Question notes. Did we do 61? 61. The 61 is fun. Yeah, that quiz is Monday on 1, 2, and 1. Now, I'm just going to pick some homework questions based on it. There might be 2 homework questions, might be 1 homework. Now, when I say 1, 2, and 1, 3, it just depends. What do I think would be the most feasible to ask? It's just something to, because the last day to drop is that Friday. So you get a case stub, here's how I ask them. And it's open note, open homework, open whatever you want to have open. That's quizzes. Yeah. And you've asked questions. But you, the things that you didn't get, you have access to anything that we've done. And I won't ask a quiz question on stuff that we haven't covered, that we haven't gone over, that we haven't. Okay. One of the toughest things about being a math teacher is dealing with the constant questions of when am I going to. I'm guilty for saying to students my first year teaching, I don't think it's better. So hospital purchases, this is, whenever, what do we have to do? Well, here's a word problem that gives us an example of how do I do it. But you wanted to know when you could use it. Yeah. So the word problem gives you a real life example of how this works. But I don't want to do it. So that's what I'm saying. Once you pass 103 out of 2, this time, trig, and stack, that's 45. We actually talk about how all hospital purchases new magnetic resonance imaging machine, MRI, for $500,000. The appreciated value reduced value by 2 years. That's the equation. 500,000 minus $47,000 for every year. From 0 to 9 years. Well, basically only measuring for 9 years. Y minus 47,000. What is the depreciated need? Something depreciated what happens. But it's reduced. It's worth less. You buy a brand new car and you drive it off a lot, it's automatically depreciated a certain percentage of what you just bought. It's worth less than what you bought with the penalty you bought. Even though you don't even have 2 miles on it, you'll think you car. Use the constraints of the model. Have a graphic utility, graphic equation using appropriate viewing window. So one of the things I like about here is I'm going to teach you to understand how to write. So we're supposed to type that in. And you have to be able to figure out what should the window? Now, it says times t. So you don't press t. This is a linear equation. When your calculator is going to graph, it's only going to graph things in terms of x's and y, when you are in y mode. So let's top mode this. You have to be in, because you have t right here. You have these four variables. Did I talk about this last time? I know I didn't the other one. You have x, t, theta, and n. So if you press this, only x is going to come. Because right now we're in the correct mode. We're graphing through mode. So, as I go down to the fourth line, it says function, powerful, instant. We're in function mode, which means f of x or y equals. Power is parametric. Pole is polar, and SEQ is sequence. The only time you're actually going to be able to press T is if you're in parametric mode. And if I'm in parametric mode and I go to my y equals, now you see I have two equations. What you are in parametric mode is you have an equation, one equation for x with respect to t, and one equation for y with respect to t. So the x variable changes with respect to t, time, and the y variable changes with respect to t, time. So you're entering your x and y ordered pairs dependent upon a single variable, time. So I can press in, 3 instead of 3x plus 1, it would be at 3. Now when I go to press the x button, it's going to be a t. Because now I'm in parametric mode. That's the way t happens. That's why it's that. Go again. If I go down here, I go to the third one, it's a completely different system of my equation. Now it's r sub 1. R sub 1 is a radius. And when I press my x button, instead of x 3 times, I try to hit x, I get 3 times theta. Because I'm in polar mode, the graph is dependent upon theta and angle. It's the radius of the graph is equal to 3 times the angle of revolution. And if I go to my window, instead of x min and x max, it's giving me theta min and theta max. So since I know my calculator in radians, I wanted to graph, let's say, 450 degrees, going 10 degrees at a time. Now, the graph is too small. So I go to zoom, fit, and back. That's what it looks like. It's a spiral. And then that's not a really good spiral, so now I do square. That's called the spiral of Archimedes. And that's from 0 degrees, 360, and it stops at 450. But that's what polar can do. You cannot graph something like this if you're in functional, f of x now. Can't do it. Can't do it. Well, you could do it if you're in parametric mode, but it's messy. That's something that we cover in, we try to cover in trip. The low, down there is for sequence. Now it's the minimum value of n, u sub n, u of n, u of n, min, d of n, d of n min. It's like, I have not introduced this to the sequence. You want to be in function. That's why when you press that x2 beta n, you're only going to get this. Now, appropriate viewing limit. Well, the only x's I care about is 0 to 9 years. So I'm going to go to my window. I'm going to get x minimum 0. X maximum 9 years. And I'll be tracked. That's how I do it. And I got nothing. Because what about the y values? What is the easiest y value to get? What's the easiest number you can ever plug in? The easiest number to actually use to plug into the equation? 0. 0 is your best bet. If we let t equal 0, then it's 500,000. So when we're here at 0, the y value should be up here at 500,000. And because you know that it's depreciating, as t goes to 9 years, the graph should be getting lower in price. Because how much it's worth is over here. It should be decreasing in price. So I need my x, my y minimum. My y minimum, if you look at my y minimum, it's down here at negative 827, and the y maximum is only 1,350. The y maximum is 500,000. So I'm going to set my y minimum at 0. Because it's not going to equal $0. And if it does equal $0, then I'm going to set my y minimum at 0 and my y maximum at 500,000. Now, you see why this line is so thick? Y scale is 1. It's putting a notch and it's counting by 1 all the way up from 0 to 500,000. Putting 500,000 little notches spaced apart. That's why it's so thick, because you can't see the notches. So I'm going to tell it to put a notch at every 50,000. My scale is going to be at 50,000. Graph utility to graph equation using appropriate field limit. If you ever don't have a clue as to what should I set my y to? Here it wasn't so bad because it's linear, but when it can get curved, Oh, we break that. So because you're using the graphing calculator, you're just doing it on your graphing calculator. If you want to sketch it, that's great. That's practice, because on your test, I need to give you full credit for work. I can't grade what I don't see. If I ask you to graph it, to show me the graph, then you got to do it. So it's not a bad thing to practice. But for the homework, basically, this is all, can you use a calculator? Can we learn how to use a calculator? You don't necessarily have to show this. And so I think I made a comment to my Tuesday, Thursday class last week. If you look for the bare minimum amount of work that you have to do, to accomplish something, you're never going to play the drums at an amazing level. Might never ever do anything at an amazing level. Think about the people you like in your life. Hang on. Think about anybody who is important to you in your life. And if all they ever did for you was just the bare minimum, what kind of a relationship is that? Whatever you're trying to do, you're trying to get your education. All you want to put into it is the bare minimum. Be prepared to get very little out of it. Example, and it's again, you're in a high jump. If they are trying to clear 5-1, they can't aim for 5-1. They're going to aim for like 5-5, but they're going to clear the 5-1. You got to shoot higher than the 5-1 if you want to clear 5-1. That's why if you guys ask me, what do I need to get on my final, what do I need to get on this test to get this grade? If I tell you what you have to get to get it, and all you do is aim for like an 82%, you probably missed the 82 because that's all you're aiming for. Do your best. I always tell them, do your best. When you walk out that door, if you can say you did your best, that's all you do. That's all you can do in any case. I did my absolute best. You don't care. Don't let anybody teach you anything except for that. So, there's the picture. As I was saying, if you are stuck and you don't know what to set the window is, we knew the x-axis had to be this. We know that. So 0 to 9. Then you go to zoom, and you just tell it to do a zoom fit, which is at the very bottom, option 10. And it is automatically going to set the Y maximum in, and it fits your picture window, so you'll get to see the entire graph from left to right. Now, if you notice, down here at the bottom, that's no longer Y equals 0. The minimum at 9, when it's 9 years, the machine is worth $77,000. But zoom fit is going to give me a perfect Y value for all the X's that I have in my domain. But it gives you a clue as to where you should have set it. Now, I like to see the x-axis. I just go down here. I'll just put my Y in. I'd like the 0. Yeah. Like the, now, B. Use the value feature of the graph utility to determine the value of Y of Y if T is equal to 5.8. So 1, 2, 3, 4, 5, 6, 5.8 is here. So the value, we want to know what this is over here. In other words, if you plug in 5.8 for X, what is the ordered pair? You can trace. If you trace, though, it's really difficult to land exactly on 5.8 without zooming. So There's a button. You get the count button right above trace. Second, count. Value, the very first one. And what that does is, it's going to tell you, you plug in any X coordinate, and it will tell you exactly the Y coordinate for that X value. If I just punch in 5.8 and hit enter, then right here, at 5.8 years, the value is $227,400. That says verify your answer algebraic. Well, that means we have an equation. So all you do is let T equal 5.8. So Y is equal to 500,000. $270,600. And 247,400. That's how you do it algebraic. And that's another thing. Do it graphically, which you can't show me on paper, but you can show me plugging it in algebraic. And when we come back from break, we will do part C. So let's come on back at 54. I'm not supposed to give you titles, right? I'm just sitting here going, right? You guys are doing it 10:20, not 10:45. I was thinking 10:45. It's like, I'm so used to going every morning from 8 to 5. Yeah, just used to it. For the last 5 and 6, 8 years. Two things. Using the graphic tab, zoom and trace. With a line is equal. Now, if you try to go to that count button, it ain't gonna work. If I go to count, and I try to hit value, it won't let me plug the Y in, it will only let me plug in the X. So tell me what Y equals when I plug in X. It won't let me plug in what the X equals when I plug in Y. What do you do? X is the independent variable. Which means it can be anything at once. And Y depends, the dependent variable, on what X is. So, great. Sometimes you have to do so you hit trace. And remember, we want a Y value of 156,900. Right now, at this point, Y is 225,500. So I have to bring it down if we were going to move it on the x-axis to the right. Slide to the right. So I'm at 162, 158, something close. And I'm passing. So it's somewhere between 7.37 years, because that's lower than I go back one, and 7.27, because that's high. So now we get trace. So that's a trace we're already assuming. But here's where you got to figure out, what do I want to assume it? Which one of these y values is closer to 156,900? Is it the 158 or was it the 153? So now I'm going to zoom. And I'm just going to zoom in. Now here it wants me to figure out, where do I want to zoom in? I can move the x-axis anywhere on the graph that I want to. I don't want to move it anywhere. I want to just enter one more time. Redraw. So now take a look in my window. Remember how it was 0 to 9 on the x-axis. Now the effects net is 6.1 to 8.4. Because in that window, that's where y is going to be 156,900. So now my window is a lot smaller. So now I go back to trace. Graph, I go to trace. So I'm at 158 like I was. Now we're going to move to the right. 156, now I'll fill with 6,900. That's less. So to the right is bigger, to the left is, to the right is smaller. To the right is smaller, but over here, that's a lot closer than the one that was over here. So I'm going to zoom in right there. So now the window is even smaller, from 7.01 to 7.5. Graph, trace, 156.75, so it must be to the left. 157, so 156 and 157.1. So I still think 156.75 there. Closer. Move there. Because again, you want exactly that one. Six, 9, 4, 5. 7, 5 is still closer because that's 25 away, that's 45. This one's closer. And I'll tell you, there are times where I get sucked down zooming rapidly. 892, that's a little closer. 9, 1, that's bigger. But 892 is closer. Eight, 9, 6, 901, that one's closer. Right? So $900 and 27 cents. So it's not exact yet. About 27 cents away. And that is 83 cents less by 27 cents away. Yeah. Oh, that's a penny away. Like that. That's 400 away. That's 600 away. And that's still a penny. Yeah. There we go. 7.3. And I'm right there at 156,908. Look at the window. $7.2999. And then I'll get 5x something over here. 7.30000044 something. The answer is right there. Now, the last part of the question says verify the answer algebraically. Algebraically just means that y equals 156,900. Negative 342,100 equals to the negative 47,000. I've got negative 47,000. Great. There are going to be times when you're not going to be able to solve something algebraically. No. Traces might be all we have. There are times where we have to let a sine curve, a transcendental function equal an algebraic function. And there's no way you can solve it with a tensor. Technology will find the intersection point. Right? And you should just practice learning how to do this. Right? 1.2. This we're just going to kind of start with. The most important word is all of mathematics. The driving force, well, the driving force is a very important driving force, is the word slope. Slope is incredibly important. It is a driving force in all of mathematics. You deal with slope every day. Slope is the measure of rise over left, the rate of change of the y-axis, or the rate of change of the y value of something divided by the rate of change of the x value of something. But it can be anything. It's just rate of change of one compared to the other. How fast you drive to school is a slope, miles per hour. Your change of distance divided by the change in your time. That's a slope. That is a rate of change comparison. It's a velocity. Okay. Acceleration. The rate of change of your velocity with respect to time. That's a slope. It measures one thing versus another. When you go up over the Great Mountain or the Chamber Pass, and you see the sign on the road that says it's a 5% grade. It didn't like take a test when you get 5 out of 100. It's the slope of the road. It's the rise and the run of the road. As a percentage, 5%. As a grade, well, you can change this to a decimal. 5% of the decimal is 0.05% per 100, or per 100, per 100 to 5 hundredths, and 5 hundredths is 1/20. So what that means is, if 5% is the rate of change, for every 1 foot you want to go up, you have to go 20 foot across. For every 1 foot you want to rise, you got to go 20 feet across. Or maybe for every 1 mile you want to rise, you got to go 20 miles across. Why? Because gravity. Cars cannot go like this. I wouldn't trust people to drive a car. Certainly, they can't come down a hill. What do you smell when you go over the Great Line or over the Chamber? What's that obvious smell? Never got a whiff of something. These days, everybody has air conditioning. So not everybody is, back in my day, first truck I bought. Yeah, I lived there on another. Actually, sold stuff without air conditioning. No power windows. You roll down the end of my power window. I have friends. Brakes. People riding the brakes and come down the brakes. Because the grade of the road is so steep. Trucks, they're not supposed to go. I think that the speed limit for a truck on the Great Line is 35 miles an hour. That's depressing when they're going downhill. Why? Because if they go any faster, they can't stop. But they're using their gears to keep them in a lower gear so they don't go so fast. What about using back manual transmission? Clutches. Yeah. Oh, that ain't old, right? Or I don't know. Yeah, I get it. But the idea is that you have to shift. And that's because that allows, when you can't go any faster, you hear the high RPMs, but it won't let the vehicle. And when automatically you go into a lower gear. And you get higher RPMs because you need more torque to get up enough, or to slow down and not go so fast you're going down, you don't need brakes on. That's what other lower gears are. point is, when you come down, if you've ever seen the ramps off to the side, runaway ramps, they go up real steep, the truck loses its brakes just before they get to the bottom of the brake pipe. They go off to the side at the very top of this huge like sand pit. So if it's stuck at the top and up just go like that. You can't go up that. It's all about slope. A wheelchair ramp. Why don't we just put a plank of wood up the stairs? Because a wheelchair can't roll a wheelchair up the stairs. They gotta go gradually up a longer run and then a shorter height. And then bike back in this way. When you go to shape. Why is it so wide and going up the mountain? Why just build a road going straight up the road? Because again, you can't do this. You gotta bike into the mountain a little bit at a time. All about the slope. The driving question for Isaac Newton to discover calculus was slope. How fast is an object moving? Not, we can figure it out if I'm here and 10 seconds later I'm over there, my total distance divided by the total amount of time to get there. That's average velocity. That's average. I might change how fast I'm walking the plane. It's just average total distance divided by total time. Isaac Newton wanted to know how fast is something moving, how fast is it moving exactly between here and there, 10 seconds. Exactly at 5.73 seconds. What is my exact velocity? Because it's at slope. Velocity is in this triangle. That's the Greek, capital Greek letter delta. You know, you might see it when you pass by a friend. Or short, that's the Greek letter delta. In mathematics and science, delta means change. Speed is the change in position divided by the change delta time. Where you are minus where you were divided by when you started and when you got there. Okay. So speed would be in calculus, the position function is S of t. So I'm just going to say your second position minus your first position, where you ended up minus where you started, divided by your second time when I got there minus how long it took me to get there when I started. The change in time. It changed me differently. Here's the problem. He have two different times. He wanted 5.7, exactly 5.78 seconds. He wanted one time over. Okay. When you get to calculus, we might even touch it a little bit in this semester. A position of an object flying through the air follows this pattern called parametric. If I start here there's my first time, so there's my first position. And then over here, there's my second time, and then my second position. And here, let's say here's my 5.78. The slope between those two would be the average velocity to get from here to here. I want instantaneous. What is exactly my speed right here? Or maybe over here, where it's not parallel, it doesn't look parallel. If I want 5.78, then I just have 5.78 minus 5.78. I want 1 point. And if at 5.78, let's say the position is 80 feet. So this would be 80 feet minus 80 feet. And the problem for Isaac Newton was when you try to calculate speed using slope at exactly 1 point. You get 0 over 0. Because at exactly 1 point, you don't have 2 points to plug in. You don't have first position and a second position. You will have only one position and only one ordered pair. 0 over 0 is, I don't know, it's called indeterminate. It's not 0, it's not undefined, it's not 1. Because it should be 0, it's got 0 in the number. It should be undefined, it's got 0 in the denominator. It should be 1 because it's something over itself. But here's the deal, if it could be all three, then it can't be any. I don't know what it is. That's indeterminate. So the way Newton and Gottfried Leibniz independently yet simultaneously discovered calculus, instead of plugging in 5.78, he takes 5.78 and a different time, and he says, we're going to let this time get really close to 5.78. And we're going to let it approach 5.78, 5.7, 5.75, 5.76, 5.77, 5.77, 5.777, 5.777. We're going to let, because you still have 2 points, 5.777, and 5.78. And we're going to let them get infinitely close to each other, and if you let them approach infinity. The distance between approaches 0, but they're approaching infinity. Then what it equals as you approach it is the same as what happens in the It doesn't matter in calculus what it equals when you get there, it matters what you approach. But it was the whole idea was slope. Calculating the velocity of planets and being involved around the sun. All about slope. I will run. They're on top Wednesday. I already took care of roll. Finish up 1.1. Finish up 1.1. And we'll finish, we'll do all 1.2 and we'll start at 1.3 on Wednesday. All right? Make sure I don't do that. Go break through. And if it was 55 on the homework, if 63 causing issues, then may I recommend just go to the my YouTube, and I did 63 because Tuesday, Thursday, met twice last week. I did 63 as their class. So if you just go to my YouTube channel and go to the playlist, and if you go to Math 3A, Tuesday, Thursday, and you see, the 20th, last week on the 20th, I covered that one in class. Okay, all right, I will see you on Wednesday.